Welcome to my channel. This series of video is for how to write the program efficiently. That is how we are going to show our skill in programming, or how we are going to differentiate our program from others program. So mainly here we are focus on the time complexity, how to reduce the time complexity. Okay. So the second way, okay, this is my third video in this series. So in the second method is, I'm going to find the problem is to check whether given number is prime or not. So I am going to check the given number is prime or not up to n by 2 values. Okay. So if the number is not divisible up to n by 2, okay, the given number is a prime. Okay. So for example, when you can take 37, that time we are going to repeat it as 18 times. Okay. 2 to 18 times. Okay. That's enough to check the given number is prime or not. Okay. And also I have one one print statement. It says how many times I am repeating the loop. How many times I am repeating the loop. Okay. So let's see how many times it's print inside the for loop. Okay. And here I am going to use one more mechanism, that is number theory division rule says a prime number is we can check whether the given number is prime or not up to square root of n times. That's enough. Okay. After square root of n, okay, no number is going to divide the prime number exactly. Okay. That's why I'm going to repeat it square root of n times. Okay, square root of n times. Okay, so how long we are going to find the value? That is square root of n. Okay, up to square root of n. Okay, so when you can go with n by 2. Okay, for 37, the loop is going to repeat this amount of time. Okay, this loop is going to repeat this amount of time. Okay, so sqrt is a function. Okay, it returns the square root of any number. Okay, it returns the square root of any number. That's why, okay, I am replacing n by 2 by square root of n. Remaining two videos are in the description box. Okay. So if you want, click on the link and watch it. I think so those videos are also useful for you. So when I execute it, okay, I'm going to repeat only square root of time. Okay, so actually when I use n by 2, okay, the loop is executed these many times, okay, to find 37 is prime. Okay, maybe the prime number is somewhat, that is n value is somewhat high. Okay, the number of execution also increased. Okay, so when I try to execute this program, sqrt is a function. Yeah, got an error. Okay, there is a need for to include the header file. So I am going to include the CMath header file. Okay, the function sqrt is available or defined inside the CMath. There is C, programming language C. Okay, so let's check. Okay, it's only going to repeat square root of n times. Okay, so automatically the number of execution time is reduced. The loop has been executed only 6 times. Then it's desired it's a prime. Okay, automatically it's desired the given number is prime. Okay, okay, when I use 35, what's going to be? Okay, 35 is not a prime number. It checks 3 times and find 35 is not a prime. Okay, 35 is not a prime. So the execution time is almost reduced. Okay, then whenever we are using this way, still we can reduce small amount of time. Okay, so whenever we are using some calculation repeatedly inside the for loop, okay, each and every time it takes some CPU time. Okay, so in every time it's required some CPU time. Okay, so those constant can be calculated outside the loop. Okay, that should be somewhat useful, somewhat supported to us to reduce the time. Okay, so each and every time we are going to calculate the square root of n and compare with I. Okay, so in for loop, every time we are calculating it. Okay, actually anyway, whenever we can find the square root of n, it's going to return a constant value. Okay, it's going to return a constant value. Then what's the need to repeat it? Okay, what's the need to repeat it? So that's why I am going to declare one variable s. Okay. It's used to find the square, that is, we are calculating the square root of n, and also the value should be assigned at, the value should be assigned at s. Okay. So here there is no repeated calculation. Here there is no repeated calculation. Okay. Already the value has been calculated and stored at s. Okay. That's why we are comparing the I value with the s. Okay. So now we can reduce small amount of time. Okay, once again we can reduce the small amount of time. Okay, here also we can use the s value. Here also we can use the s value. Okay, so let's execute. Okay, this is also used as to save small amount of time. We can get the same output, yeah, but it should be executed somewhat less time. It takes only less time.